Hey everyone, and welcome. Today, we're jumping into a really fundamental networking concept, how you actually get different VLANs to talk to each other. We're going to break down the classic router on a stick method.
All right, so you've done the right thing. You've set up your virtual LANs, creating these nice, secure, totally isolated networks. Awesome. But then, you hit that wall. What happens when someone on the staff VLAN needs to print to a printer on the student VLAN? How do you actually bridge that divide? And that exact scenario brings us right to the heart of the matter, the core challenge we're going to solve today, the VLAN communication problem.
Check this out. It really helps to visualize it. Even if all your computers are plugged into the very same physical switch, your staff and student VLANs are living in completely different worlds. They're what we call separate broadcast domains, which is just a fancy way of saying they're like two houses with a brick wall between them. The noise from one just doesn't get to the other.
So just to be super clear here, if a PC in the staff VLAN tries to send anything to a PC in the student VLAN, it's going to fail. Every time. And that's not a bug, it's a feature. That's the whole point of VLANs, to create that secure isolation.
So, how in the world do we fix this? Well, we have to move up the network stack. We need something that can act as a bridge over that wall. What we need is routing. Okay, just a quick refresher. VLANs are a layer 2 concept. They live at the data link layer, which is all about getting traffic around on a single local network. And that's why they're so good at keeping things separate on a switch.
But routing, on the other hand, is a layer 3 process. It doesn't care about MAC addresses, it works with IP addresses. Its entire job is to move traffic between different networks. And that's the key we need to unlock this whole thing.
And this right here, this is the mental shift you have to make. To a router, VLAN 10 isn't just a group of ports on a switch. No way. It's a completely separate IP network, say 192.168.10.0, and VLAN 20 is another one, maybe 192.168.20.0. And as soon as you have different IP networks that need to talk, you need a router, period.
So, with all that groundwork laid, let's introduce the star of the show. It's a really clever and efficient solution, and it's time to meet router on a stick.
You know, back in the day, this was kind of clunky. If you wanted a router to handle two VLANs, you literally needed two physical cables running from the router to the switch, one for each VLAN. It worked, but it was a mess and a total waste of ports. The new way, router on a stick, is just so much smarter. It uses a single special connection called a trunk link to carry the traffic for all of your VLANs at once.
So what is it exactly? Well, you take one physical port on your router and connect it to a trunk port on your switch. Then, inside the router software, you create these little virtual interfaces. We call them subinterfaces, and you assign one to each VLAN. It's amazing. One physical connection does the work of many.
Okay, so that's the big picture. Now let's roll up our sleeves and get into the nitty-gritty. We're going to trace exactly how a piece of data flows through this whole setup.
And this brings us to the absolute most important question in this whole process. If all this traffic for all these different VLANs is flying up a single cable, how on earth does the router know which packets belong to the staff and which belong to the students?
The answer is this beautifully simple and powerful standard called 802.1q tagging. Because that connection is a trunk link, every time a frame leaves the switch adds a little digital tag to it that says, hey, I'm from VLAN 10, or I'm from VLAN 20. The router just reads the tag. It's that simple.
So let's look at a real piece of configuration. Now, don't get hung up on memorizing the commands. Just focus on what each line is telling the router to do. We're going to walk through this piece by piece.
All right, first up, interface G0/0.10. See that little .10 at the end? That's the giveaway that this is not a physical port. We're creating a virtual logical subinterface on the real port, G0/0. And by convention, we just match that number to the VLAN ID to keep things organized.
Now this line right here, this is the magic. Encapsulation.1q10. This command connects the dots. It's telling that virtual interface we just made, hey, your only job is to pay attention to traffic coming up this trunk that has been tagged with VLAN ID 10. It's basically a filter.
And finally, we give this virtual interface an IP address that belongs to that VLAN's network. And this is critical. By doing this, we've just created the default gateway for every single device in VLAN 10. Whenever they need to talk to another network, this is the address they'll send their traffic to.
So let's put it all together.
A PC in VLAN 10 sends a packet to its gateway, our router's new virtual interface. The switch gets it and slaps on the VLAN 10 tag. That tag frame zips up the trunk link where the router's .10 subinterface is waiting to grab it. The router then strips off the tag, looks at the destination IP, sees it's for the VLAN 20 network, and makes a routing decision. Finally, it sends the packet back down the trunk, but this time it's aimed at the .20 subinterface, which tells the switch exactly where to deliver it. And just like that, we have communication.
Okay, understanding that flow is awesome, but why do we spend so much time on this one method? Let's zoom out and talk about why this concept is so incredibly important in the world of networking.
Look, router on a stick isn't just a configuration. It's like a perfect little masterclass in how networks really work. It forces you to see how Layer 2 isolation, with VLANs, and Layer 3 connectivity, with routing, have to shake hands and cooperate. It's the perfect lesson on trunking, default gateways, and it even lays the groundwork for more advanced stuff like Layer 3 switching.
This also helps us clear up some really common points of confusion. So, what are the big takeaways? 1. VLANs cannot talk to each other without a Layer 3 device like a router. It's just not possible. 2. Switches are for forwarding traffic locally. Routers are for making decisions to send traffic between networks. And 3. A default gateway is absolutely essential. Without it, your devices are just stuck in their own little bubble forever.
Now, this method is fantastic. It's great for learning, it's perfect for smaller networks. But it does leave us with one final, very important question. That single stick, that one physical cable, has to handle all the traffic for every single VLAN. What happens when your network grows and that one link gets totally overwhelmed and becomes a bottleneck? Well, that is the question that leads us to the next evolution of this technology,